Rightio. Now, there's a number of environmental issues with the coal seam gas industry, and it's an emerging industry, and because of that, there's a whole range of regulations which have not previously been in place, which are in the process of coming through. The issue that we're most interested in is a product called associated water. When the coal seam gas company is drilling down into the coal seam to liberate the gas, the natural gas, the coal seam's under pressure, the coal is surrounded by water, and once that pressure is released, the water which is in the coal seam comes up. Now, it's a byproduct. It's not something that the coal seam industry particularly wants. In fact, they'd love for their bores to run pure 100% gas because that's what they're selling. But the associated water is a fossilised water. It's been basically down there under pressure since that coal seam was formed, and it's not the normal groundwater which is brought up for the agricultural industry. That's much higher up. It's refreshed from the rainfall. That stuff's been down there for millions of years, and it's got a lot of salts associated with it. So the big issue with that water is that it's got a very high salinity, and the majority of that salinity is coming through in a sodium salt. And the last thing that Australian soils need is more salts, particularly sodium salts. So what we're looking at doing is removing that sodium and making that associated water a lot friendlier, a lot more sustainable to use as an agricultural water. Because by hook or by crook, if you're harvesting the gas, that water's going to come up. But as we learn more about the water, we're handling the treatment differently. In the very first stages of the industry, the water was being evaporated away, but that left the salt in the soil and was contaminating relatively large areas of land. From there, we've moved on to looking at aquifer injection, so putting the water back down into the aquifer, but that's very energy intensive, and it's got a few issues about will that water, once it's put back in the aquifer, stay there now that the surrounding area has been fractured? Will it migrate into the freshwater aquifers? So there's concerns there. Then we started looking at putting in very large reverse osmosis plants, which are very similar to the desalination plants which have been installed at the Gold Coast, down in Sydney, Melbourne, Adelaide. But they're also very energy intensive, and the water which goes through them costs a great deal per megalitre. And so the agricultural industry can't really economically purchase that water if it's gone through a reverse osmosis treatment process, and it also means that it's really increasing the expense for the coal seam companies to treat that water to that level. And the issue with it is it's so pure, it's so devoid of salts that we actually have to add things to it, otherwise it does exactly the same type of harm to the soil. So it's one of these things where you want to be in the middle. So associated water on its own is on the right-hand side of the bell curve. It's got too many contaminants of concern. Reverse osmosis water is on the left-hand side of the bell curve. It's so pure that it also has sustainability issues when you add it to the soil. So being able to be somewhere in the middle is exactly what we're trying to do with this research. We're trying to reduce the sodium salts, and we'll actually increase the calcium and the magnesium salts, which are beneficial for soil health. Well, we're using a natural volcanic rock which has got cation exchange capabilities. Now, what it basically means is that you run the water over the rock, which is nice and simple. Trickling rock filters have been a standard technique used in the water industry for getting close to 130 years. So there's a whole range of technologies which are set up within the water industry to allow these trickling rock filters to take place. But what's going on is that these volcanic rocks, they've got an electronic imbalance. And so a cation is something with a positive charge. So sodium's got 1+, calcium and magnesium, they're 2+ in their chemical formula. So the rocks themselves have got negatively charged, and they'd like to bring positive charges into the structure of the rock. Now, each volcano made its own, and zeolites, these natural rocks, have been used for many years in the water industry in municipal swimming pools, because ammonia, what we excrete in our urine, has got a positive charge. And if you think about a swimming pool and you've got thousands of kiddies in there, out of there, every day in some of the larger pools, and you want to remove something which is positively charged associated with urine, well, having a rock filter where you can pass the swimming pool water through to remove one of the more offensive components of urine in a nice, simple, energy efficient way. We're taking the most unsustainable components out of the water, which is the sodium, and putting calcium and magnesium back, which actually improves the quality of the water both as an irrigation water for the plants and as an irrigation water for the soil. So improving plant health and soil health at the same time. But doing that through the one process which is much more energy efficient than a reverse osmosis desalination treatment plant. So there's a whole range of environmental and economic sustainability benefits to this treatment process.